Math 3, Unit 3, Section 2, Part B. The first thing we're going to talk about today is the multiplicity of an X-intercept, and that is the number of times the particular X-intercept occurs. So we briefly talked about this yesterday, but basically if you look right here, there are two X minus 2's, right? Because it's squared. And so that has a multiplicity of 2. What does this have? A multiplicity of 3. Very good. Okay, so this question says, state the X-intercepts with their multiplicities of the following polynomials. So we are going to go ahead and break down each of these factors again, just like we did. This right here stands for what? -1. -1 equals 0. Does that work? No, so this is not actually a solution. It's not an X-intercept. When we set x minus 2 equal to 0, what does that equal? Good, x equals 2. And what multiplicity is that? Very good. Okay, this right here, x plus 1, when we set that equal to 0, what does x equal? Very good, and that has a multiplicity of 3. Okay, and then x plus 7, that will make, good, and that has a multiplicity of 1. We're going to come back to these examples because the different multiplicities will tell us what the graph looks like, but we're just going to leave this here for now and do the next example. Okay, so same thing where we're going to set each of our factors equal to 0. So when we set -2 equal to 0, that doesn't work, so that's not a solution. X minus 3 equals 0 will make what? Good. And that has a multiplicity of, very good. X plus 1 will make, good, x equals -1, and that has a multiplicity of 2. And then last, when I have 1 minus x and I set it equal to 0, what does it equal? Very good. And if you're ever unsure, actually just write it out and solve. And so x has to be positive, and so that's how I end up getting x equals 1. Because 0 plus x is x, and then you have 1. And that has a multiplicity of 1. Good. Okay, so this next part, and then we're going to come back to these problems here, states that the multiplicity of an X-intercept, if it's odd, then the graph passes through the X-intercept. Okay? If the multiplicity is even, then the graph of the polynomial bounces, which means that it touches but it does not pass through at the X-intercept. So if you look down here at this graph, this is showing you, see here how this line is passing through the X-intercept? And then here it's bouncing, like it's touching at the point, but then it turns around. This actually makes what type of point? What do we call that? Very good. This is a relative max, because it's a relative maximum value because everything below it is smaller. Okay, this also is a bounce. Notice how it touches and then it turns back around. Again, this would be a relative maximum. And then see this one, how it's just passing through the point. Okay, so odds, these ones pass through, and I normally give them a letter of P, and then evens bounce. So if we go back to these examples, at x equals 2 and it has a multiplicity of 2, is that one going to bounce or pass through? Good, this one will pass through. The multiplicity of 3 here, this one will bounce. No. Go back here. Oh my goodness. Yes. So this 2 was bounce and the 3 is pass through. Thank you. And then the 1 will be pass through. Good. Okay, on H, multiplicity of 1 will pass through, 2 will bounce, and 1 will pass through. Okay. So now we're going to put all this into graphing. Okay, are you guys ready?
No.
Not yet? Okay, we're good? No? All right. So there is kind of a lot of stuff we have to do when we are graphing. Okay, so we need to find all the X-intercepts. We have to figure out, is it going to bounce or pass through at those values? You need to know your Y-intercept. You need to know the end behavior of your graph, and then you're going to draw your graph. Okay, so we're going to use this space here below to find all the information. Okay. So does anybody have an opinion as to where we should start? Okay, sure. Let's start with step 1. That's great. So find and plot all of the X-intercepts. So if we are dealing with our X-intercepts, okay, and this has already been factored for us, what will be my X-intercepts for this problem? Okay, so we have x equals -2, and we have x equals 1, and we have x equals -3. Now, each of these multiplicities are what? 1. This has a multiplicity of 1, multiplicity of 1, multiplicity of 1. And what does it mean when you have a multiplicity of 1? Each of these pass through. So we could actually plot these points on the x-axis. So we have a point at -2. I oftentimes will put the p there with it so that when I start graphing it, I don't have to go look somewhere else. I have all the information there. We have a point at 1, and again, that one is passing through. And then we have a point at -3, which is also passing through. Okay, questions up to this point? Okay, so next it says find and plot the Y-intercept. Who remembers how we find the Y-intercept? Very good. So Y-intercept here, we're going to go ahead and write this as y equals -0 plus 2 times 0 minus 1 times 0 plus 3. I'll move this up so you can see my work a little better. So all we did was plug in 0 for our x's, and then we're going to simplify. So the negative in front, it's really a -1. 0 plus 2 is 2. 0 minus 1 is -1, and 0 plus 3 is 3. And we multiply all those together, and what does it equal? 6, a positive 6. So remember that 0 on the x-axis and then 6 on the y. So my y-intercept, we are going to go up to 6 and make a point. Okay, so step 3, find and mark out the end behavior of your graph. Okay, so for my end behavior, which we're going to label as EB, what do we need to know? Because we want to find out our right end behavior and our left end behavior. But before I can actually say anything about that, we need to know what 2 things? Very good. Degree and leading coefficient. Okay, so going back to our problem, what is the degree of this problem and how do you know it? So the degree for the first parenthesis is 1. The degree for the second parenthesis is 1. The degree for the third parenthesis is 1, and we add that together, and that is 3. Very good. So my degree is 3. Okay, now leading coefficient, how do I find that? Yeah, we're going to multiply together all of the leading coefficients for each of the factors. So the first factor, the leading coefficient, is negative 1. Okay, so I'm just going to write this over here. Negative 1 times the leading coefficient of this factor is what? 1, because it's the value in front of your variable. So if you have an x, there's really a 1 in front. This one is also 1, and this one is 1. And we multiply all that together, and we get negative 1. And so my leading coefficient, negative 1. Okay, so my right in behavior will be what? And how do I know it's negative infinity? Because my leading coefficient is negative. Now, what is my left in behavior? Positive infinity. How do I know it's positive infinity? Degree is odd, so that means that the end behaviors are opposite. Does anybody want to ask any questions about any of this? Okay, so based on this information, on the right side, I'm going to have an arrow going down. And on the left side, I'm going to have an arrow going up. So I know that once I put everything in there, the arrows should end up going in those directions. Is that okay? All right, and then now we're just going to draw the rest of the graph. So since it's passing through, you can start here, and it passes through that point and then turns around. And then it's going to pass through that point, turn around, pass through this point. And this doesn't look, you know, pretty. You guys can make it look nicer, I'm sure. But that's it. And everything connected and worked out correctly. Okay, if for some reason you're passing through and this is going down, but when you're passing through it should be going up, then you know that maybe you did something wrong. Okay? Do you have questions? All right, so let's go ahead and try another one here. So we have J. So let's start again with our X-intercepts. And what will be my X-intercepts here? What happens with x squared? Can it equal 0? Yeah, right? And x can equal 0. It's just when you have a number in front, that can't equal 0. Like a 5 can't equal 0, a 1 can't equal 0. But an x can equal 0. So my first one is x equals 0. And that has a multiplicity of what? 2. And then x minus 1 equals 0 would make x equal 1. And that has a multiplicity of 2. And then we have x plus 4 equals 0, and that will be x equals what? And that has a multiplicity of 1. And so each of my multiplicity of 2's are what? Very good, bouncing. And then multiplicity of 1 is passing through. So let's go ahead and mark those on our graph. So 0, we have a bounce. At 1, we have a bounce. And at negative 4, we have a pass. Okay, I'm going to pull a stick for this next one, and I just want you to tell me, how do I find my y-intercept? What am I going to do to find that? And Vanessa, how will I do that?
You find the y-intercept by plugging 0 to the equation on top.
Very good. And we plug zeros in for each of the x's in the equation. So we would write this as y equals 0 squared times 0 minus 1 squared times 0 plus 4. Well, on this one we get a 0 times 1 times 4, because negative 1 squared is positive 1, correct? But 0 times anything is just 0. And so my y-intercept is at 0, 0. Does that make sense? And actually, if you look at this graph, do you see how it already is intersecting the y-axis at 0? So in this case, you don't have to necessarily find the y-intercept by plugging 0 back in, because you already have a y-intercept. So anytime you have a y-intercept at 0, or I mean an x-intercept at 0, that's also your y-intercept. But it doesn't hurt to go through this either. Okay. So next step is our end behavior. So for our end behavior, we need to know our degree. So I'm going to go ahead and do this at the top so we can see everything this time. So what will be my degree for this problem?
2.
Okay, so let's talk through this. What's the degree of x squared? 2 plus 2 plus 1. Does everybody understand where we're getting the 2 and the 2 and the 1? From my exponents, right? There's 2 x's here. There's 2 x minus 1's here. There's 1 x plus 4. And we add that together and my degree is 5. Okay, the other thing we need to know is our leading coefficient. Okay, so I'm going to have somebody, I'm going to pull a stick, walk me through how I find my leading coefficient, what numbers I'm going to end up multiplying. Okay, Caitlin, how do I find my leading coefficient? Good. And so this first one, the number is 1. Good. The number in front here is 1, and then the number in front of my x plus 4 is also 1. Good. And so we multiply that together, and we get 1. And so my end behavior on the right side, I'm going to pull a stick for this too. What will the end behavior on my right side be, and why? Avery, do you know what it'll be? You. Okay, so on the right side, do you know what my end behavior will be? Is it going to be positive infinity or negative infinity? And if you don't know, it's okay. I know you haven't been here. Good. Do you know why? Good, because your leading coefficient's positive. Very good. If the leading coefficient was negative, then it would have been negative infinity. Good job. Okay, and my left end behavior for another stick, please tell me what it is and how you know it. Shelby is not here. Just kidding. Ashley. You. Sorry.
It's going to be negative.
Good. And why is very good? Negative infinity because the degree is odd. Perfect. Okay. And so we know that on the right side it's going to go to positive infinity. And so I'm going to mark an arrow going up. And then on the left side I'm going to have an arrow going down. And if you wanted to, you could actually go from the left point. That might make a prettier graph if I did something like that so it connects better. But on the right side, positive infinity, left side, negative infinity. And then now you're going to finish drawing. So passing through means we go through the point, right? Bounce means it touches, but it doesn't go through and it bounces up. So same thing, each of those are bounces. So see how it's touching and then it goes back up and then it comes down, it touches, and then it goes back up again because there was 2 bounces. All right, do we have any questions on this? Okay.